Welcome, this is the IM2 video lecture on transforming quadratic function, part 2. The learning target is the same as part 1, is to understand how a parabola transforms. The 3 success criteria that you should be able to do after this video lecture is to 1. Find the vertex and describe the transformation. 2. Write the vertex form for a transforming parabola. And 3. Describe the transformation for a parabola. First, the core concept. Translating the parabola can be looked at from the vertex, which is parentheses h comma k, close the parentheses. The k is the vertical, that is up and down. Originally, when k equals to 0, it is the blue. When you add a k value, the parabola moves up, and if you subtract the k value, it moves down. H is for the horizontal, left and right. When h equals to 0, it's stationary. When you subtract h, the parabola moves left, and if you add h, the parabola moves right. Now we're going to practice. Given that as the vertex form, please find the vertex and describe the transformation. Please pull up Desmos to do this. Here we are going to enter the function of g of x. G of x is equal to x plus 2 squared plus 5. And you saw here the vertex is negative 2 comma 5. The original can be seen as from x squared. So from the blue to the red, you should see that the parabola moves 2 to the left, then 5 up. Let's do that for 2, 3, and 4. Number 2, the vertex form. That's graph to see. You go 4 to the right, then 4 down, because the vertex is at 4 comma negative 4. Number 3, the parabola just moves 2 to the left, where the vertex is negative 2 comma 0. Number 4, here you saw that the parabola moved 5 to the left and 1 up, because the vertex is negative 5 comma 1. The next thing is looking at this example. Now we are going to write vertex form for a transforming parabola. So given the parent function as that, you're going to write the vertex form for the function after it moved 2 units to right and 4 units up. If you would like to see how I set this up on Desmos, is I type in the function with all the variables. Desmos is going to have this option right here. It says to add the sliders. Hit all and they're going to pop up. The parent function is f of x is equal to x squared. So set this to the parent function. A equals to 1, h was equal to 0, and k was equal to 0. This is the original parent function. Right? Now we're going to adjust this based on how it moves. And it says it moves 2 units to the right. That is the h value. If I slide it left, it moves left, and if I slide it right, it moves right. I go to the value of 2 to represent the parabola moving 2 units to the right. Then I go up 4 so I slide the k value to the right until it hits 4. Okay, that would be what the parabola is. I'm just going to paste the vertex form here. Now put in the values that I saw. A was equal to 1. H, replace h with 2 and replace k with 4. Notice that my parabola matches. So my original was red, and then the one I figured out once I plugged it in was purple. So it matches up. Here you go. Those are the steps if you would like to see it. And you could always graph to double check your answer. Let's do that one more time. Let's make sure we reset this to the original parent function of x squared. It says to reflect the parabola over the x-axis. So this has to be a negative 1. And it says for it to have a vertical stretch by a factor of 2. So if I increase it, is it stretching? No, that is compressing. So it goes from here and so we want it to vertically stretch, okay? So you want to, if you stretch it, it gets wider. Do you see that? Perfect. So it's going to be a half because that is the factor of 2. Okay. Then we're going to go right 3. So that is my h value. And I'm going to move that all the way to 3. There was no movement up or down. So I do not touch the k value. Right? So let's plug this in. A was your negative 1/2, which is your negative 0.5. And your h was 3. K was 0. So you could write plus 0 or you can leave it out. Notice these two match up perfectly. All right. Label. Your reflect is when a is negative. Vertical stretch. Your a equals to 1/2 because vertically stretch is when a is a fraction in between 1 and 0. Right 3 is h equals to 3. And substitute it in. There you go. All right. So I'm going to show you one more practice problem. Okay. Let's take a look. In this problem, I'm going to write the vertex form for a function after reflecting over the x-axis, moving it 5 units to the right, left, 5 units to the left, and 1 unit down. So let's reset this. All right. So it says reflect over the x-axis. So the a, to reflect it, we have to make it a negative. So it becomes -1. The h, our movement is going to be 5 to the left. So I move this to the left 5 until it hits 5. Let's zoom out. Good. And k is 1 unit down. So I move this to -1. Perfect. So the parabola, 5 units to the left, 1 unit down, as well as a reflection. So let's substitute it in here. All right. So a was your -1. Your h here was a -5. So let's put a subtract 5 here. And your k is -1. Okay. Parentheses -1. Look, why is it off? Okay. Notice it is off. My parabola is actually to the right 5. I want it to the left. I made a mistake here. Okay? Because when you substitute here where the h is, you subtract h. Your h was a -5. So make sure you're putting parentheses -5 here. Okay? And it should match up. Let's see it here. So we already covered this part. The hard part is when you plug it in. Watch. The h, the vertex form is a parentheses x minus h squared plus k. Notice, when you plug in the value for h, make sure you put it in a parentheses. Then you're going to see there's a negative and a negative. A negative times a -5 becomes a +5. All right? That's why when I graphed this, it made sense. There you go. So I can write here just +5. And you see how these two match up? All right. So there you go. That is part 2 of the transforming a quadratic function.